Yes, good morning, my dear students. This is again your Virat Kumar, lecturer in Electrical and Electronics Engineering from the Institute of Government Polytechnic, Vaddapalli. With the same semester 4, the subject of AC machines with the code of 18EE403C from the major topic of three-phase transformers. We are going to see about the power measurement with the help of instrument transformers. That is the power measurement with the help of instrument transformers. Small recap of the previous PPT or the previous class. In the previous class, we have learnt about what is instrument transformer, what is CT, and what is PT. So these are the things which we have seen in the last class. Actually, by using CT, we have measured the values of the current, and by using the PT, we have measured the values of power of high range value, not power. By using PT, we have measured the voltage of high ranges, and today we are going to see the power measurement by using these both. So a CT can measure only the value of current by single, and the PT can measure only the value of voltage by single. But we know the power is a combination of voltage and current. So these both together can measure value of power. So the objectives are, on completion of this period, you'll be able to know the power measurement with the help of instrument transformers. Power measurement with the help of instrument transformers. So you can see a small connection, not of single phase power measurement, and you have a PT over here and a CT over here. PT is always connected in parallel since it is voltmeter, just like voltmeter, and CT is always connected in series, just like an ammeter. So you can see here you have a high voltage supply, and thereby it is connected to the load. In between we have arranged PT, CT and wattmeter, and also small voltmeter and ammeter. You can see CT is current transformer, CC is here. In wattmeter you may know that CC is current coil, that MLCV are main line coil and volt. So in the same way you can see that A is ammeter, PT is potential transformer, PC is pressure coil, this is pressure coil and this is the current coil, and where V is voltmeter. Now we'll just see the connections. See here, high voltage supply which we have directly given to the load. In between, let us assume that this is phase and neutral. Now this is phase and neutral, so you can see the PT, both the terminals are connected to it, so thereby it is connected in parallel. And then the other two terminals are connected, one of the terminal to V of the wattmeter and the other to C of the wattmeter. This is V, and just indicate it, MLCV. M is main, L is line, C is common, V is volt. and thereby you can also see that a voltmeter is also connected across the PT secondary, and CT is connected in series with the load, and the other again connected in series with the two terminals are connected, the other to M and the other terminal to L. In between there is an ammeter connected in series. So thereby this is the overall connection of the single phase power measurement. By this, so here you can see the wattmeter. This wattmeter shows us the range of power of the circuit. And I'm moving on to the next connection procedure. So you can see the wattmeter along with CT and PT connection to measure power in high tension circuit is shown in the previous figure, the previous slide. And the primary winding of the CT is connected in series with the load. The primary winding of the CT is connected in series with the load. The secondary winding is connected in series with an ammeter and the current coil of a wattmeter as shown in the previous. And the primary winding of the PT is connected across the supply, and a voltmeter and potential coil of the wattmeter are connected in parallel with the secondary winding of PT. We can observe here the connection procedure, how the circuit diagram was made. It's very clear in this point. We'll see it again, that the wattmeter along with CT and PT connection to measure power in high tension circuit is shown in the figure. And here the primary winding of the CT is connected in series with the load, as we know that we have seen in it. And the secondary winding is connected in series with an ammeter and the current coil of a wattmeter, that is CC. The primary winding of the PT is connected across the supply, and the secondary then a voltmeter and potential coil of the wattmeter are connected in parallel with the secondary winding of PT. Then the power can be measured is equals to K into actual ratio of CT into actual ratio of PT into wattmeter reading. Thereby K is equals to correction factor, that is equals to cos pi by cos beta into cos alpha, and where pi is equals to phase angle between voltage and current of the load, and whereas alpha is equals to phase angle between currents in the current coil and pressure coils of wattmeter, and beta is phase angle between current through the wattmeter pressure coil and voltage across the wattmeter pressure coil. So you can see the elements, overall elements, that finally a power can be given by, which is equals to K into actual ratio of CT into actual ratio of PT into wattmeter reading. So these are directly obtained from the meters, and whereas K is equal to correction factor, that is given by cos pi by cos beta into cos alpha. whereas pi is equals to, we all know, phase angle between voltage and current of the load, and alpha is equals to phase angle between currents in the current coil and pressure coils of wattmeter, and whereas beta is equals to phase angle between current through the wattmeter pressure coil and voltage across the wattmeter pressure coil. That is angle between current through the wattmeter pressure coil and voltage across the wattmeter pressure coil. That means the angle between current and voltage of wattmeter pressure coil. Moving on to the next slide. Now the three-phase power measurement with the help of instrument transformers. Connection procedure. It is a 2 wattmeter method of measurement of three-phase power, and 1 voltmeter is connected across the secondary of three-phase PT. 1 ammeter is connected in series with secondary of CT1 and also in series with current coil of wattmeter 1. Second ammeter is connected in series with secondary of CT2 and also in series with current coil of wattmeter 2 as shown in figure. The total power consumed by the load is given by the sum of total 2 wattmeters, therefore W1 plus W2. So in the previous case, already connection was shown and explained about the connection procedure. Now we are explaining you about the connection procedure, and then we'll just make the diagram. See, it is a two. Actually, in order to measure a three-phase power, we just required 2 wattmeters. 1 wattmeter is not sufficient. Actually, it requires 3, but 2 is more than enough. So it is a 2 wattmeter method of measurement of three-phase power, and 1 voltmeter is connected across the secondary of three-phase PT, and 1 ammeter is connected in series with secondary of CT1 and also in series with current coil of wattmeter 1, and second ammeter is connected in series with secondary of CT2 and also in series with current coil of wattmeter 2 shown in figure. And the total power consumed by the load is given by the sum of 2 wattmeters, therefore W1 plus W2. And we'll see the diagram. In the previous case, we have seen the power measurement of a single phase supply, and here it is a three-phase. Previously it was single phase power measurement, and now it is a three-phase power measurement. So in three phase we have three connections R, Y and B, and here you require 1 PT, 2 CTs and 2 wattmeters. So you can see this is a PT, and here you have CT1 and this is CT2, this is CT1 and this is CT2. CT is current transformer, this is wattmeter 1 and this is wattmeter 2. You can see here wattmeter 2 and this is wattmeter 1, and you require 1 voltmeter and 2 ammeters for both the CTs. For CT1 A1 and for CT2 it requires A2. Now slowly we'll just see the connection, which will be similar to that of the single phase power measurement. So all the three phases are of the primary of PT, are connected to all the phases. By that it makes a parallel connection. And then the secondary is connected to one of the phase. Let us take R phase. R phase is connected to pressure coil of wattmeter 2, and then it is again connected to Y, and then it is again connected to pressure coil of wattmeter 1, and then it is connected to B. Thereby the circuit gets closed. It means all the three phases are connected to the pressure coils of the both wattmeter 1 and 2. And now let us move on to this CT. This is CT1, which are connected in series in any of the two phases. This is CT1 in B phase, and the secondary is connected in series to the ammeter and then to the current coil, and then at the terminal. By this the circuit gets closed. I'll just here you can see this is a okay. So CT1, this is CT1, CT1. So one primary is connected to the load, and the secondary to the current coil and to the ammeter, then thereby circuit gets closed. Similarly, CT2 is connected in series with a R phase and to the load, then the secondary is connected to the current coil of wattmeter 2 and then ammeter, and then circuit gets closed. All these are connected in series. You can see here simply it's just like a single phase power measurement. The connection was just like a single phase power measurement. Instead of one wattmeter, here we have two, and instead of one CT we have here two, and there are only two terminals, and here we have three, R, Y and B. Moving on to the next slide. So that's it for today's class. So we shall see a summary. We have discussed about power measurement in single phase and three phase circuits in conjunction with instrument transformers. And lastly, we haven't seen the power measurement formula for three phase. Actually, it is same or similar to that of the power measurement of single phase measurement, where we have seen that K is equals to where P is equals to K into ratio of CT into ratio of PT into where P is equals to, you can see, K into actual ratio of CT into actual ratio of PT into wattmeter reading, and K is given by cos pi by cos beta into cos alpha, as we have seen. For that the same comes to this, but here the wattmeter reading is for both W1 plus W2. And the power in a single phase supply is directly given by the wattmeter. The power in a three phase supply is given by the sum of two wattmeters, that is two wattmeter method connected. So these are the things which we have discussed. I hope you have got some idea. So moving on to a small quiz. The primary winding of the CT is connected in series with the just guess the answer. The primary winding of the CT is connected in series with the supply, a load, a wattmeter, or voltmeter. We can simply say that actually from viewing the diagrams, connection diagrams, the primary winding of the CT is connected in series with the load. Actually, we can see in the previous cases for the measurement of power in single phase and also in three-phase power measurement. The primary winding of the CT is connected in series with the load. We will check the answer. Actually connected in series with the supply is also right and also load is also right actually, as we have seen that from the supply and there was a CT over here this way, which is directly connected to the load, and here there is a supply. So in this case these both the answers are right actually. So both the cases are right. From this you can see that it is connected in series to the supply and also in series to the load. So both the answers are right. The next question, the pressure coil of wattmeter is connected across. It's also very easy. Pressure coil of wattmeter is connected across. So we can recollect from the before topics that the current coil is connected across CTs, secondaries of the CTs, and a pressure coil is connected across the secondary of PTs. So from the secondary of PT means B is right answer. We'll see. So B will be the right answer. We'll check the pressure coil will be right. The pressure coil of wattmeter is connected across. Yeah, the secondary of PT. It's a secondary of PT. Okay, moving on to the next question. The secondary of CT is short circuited by. The secondary of CT is short circuited by. This is also very easy in the previous case. Actually, the secondary of CT is short circuit only. The circuit get closed by actually with the ammeter and also the current coil of the wattmeter. So in this case both A and B are right. So in this case both A and B are the right answers. So let us see. No, he is telling that this is wrong. Actually this is the right answer. See, the secondary of CT is short circuited by actually with ammeter and also current coil of wattmeter. So this will be the right answer. The next question. Instrument transformers are used to extend the range of. Instrument transformers are used to extend the range of. Actually, it's all the above. See, it is all the above. Actually, it is used to extend the range of all voltmeters, ammeters, and wattmeters also. So it is all the above. All the above is right. So there are some frequently asked questions in it. Draw the circuit diagram and explain the power measurement in single phase circuit with the help of instrument transformers. And also draw the circuit diagram and explain the power measurement in three phase. This is for single phase and this is for three phase circuit with the help of instrument transformers. Thereby ends the session. Thank you.